There are nights when the solar system feels especially quiet, so still that even the planets seem to be drifting half asleep in their orbits, humming the same loops they've kept for billions of years. And then, without warning or fanfare, something unusual wanders through that quiet. Not a comet we misplaced, not an asteroid we forgot to catalog, just a traveler. One that didn't come from anywhere nearby, one that didn't announce itself, one that slipped into our celestial neighborhood the way a shy stranger might slip into the back row of a silent theater, already halfway through the show. Oumuamua entered the solar system like that, quietly, gently, and with absolutely no intention of stopping. If space had doors, this thing didn't knock. It just walked in, glanced around, and kept going. Not out of rudeness, more out of the kind of cosmic confidence possessed only by objects that have been moving for so long, they have forgotten what destination even means. Before we drift through the quiet mystery of Oumuamua, take a gentle moment to like and subscribe to the Late Night Scientist channel, and let me know in the comments when and where you're listening, so this peaceful science can reach more sleepy minds, easing into rest. Before anyone knew it was here, it had already crossed past the orbit of Mercury, swinging in behind the sun as if trying not to be noticed. For a while, it wasn't. The solar system is vast, and we are small observers parked on a tiny blue dot, looking out from behind layers of atmosphere, hoping not to blink at the wrong time. But in the background of that cosmic stillness, this visitor had already begun its long curve around the sun, like a stone skipping once across the entire system, touching only the bare minimum before flying off again. To imagine its arrival, picture an object shaped like something a galaxy might accidentally misplace. A shard of something long forgotten, a remnant of a place with different rules and a different sky. It drifted forward not with urgency, but with a kind of ancient patience, as if its motion had been decided ages ago, and it was simply honoring the appointment set by physics. Nothing rushed, nothing delayed. A speed chosen by the quiet logic of momentum. No whistles, no glowing tail, no cosmic spotlight. If anything, its entire presence seemed to whisper, "Don't mind me. I'll be gone in a moment." And that whisper fits it perfectly, because Oumuamua did not come here for us. It didn't enter our system with purpose, and it certainly didn't modify its behavior upon being noticed. This is the kind of object that could pass by entire civilizations without adjusting its path even a fraction. The cosmic equivalent of a tourist wandering through a city without looking up from a map written in a language no one here speaks. The humor of it, very quiet, very subtle, is that it didn't stop because stopping wasn't part of the script. It had been traveling for so long that the idea of pausing probably went extinct before our sun was even born. It had no reason to visit, but it also had no reason not to. That's the strange beauty of interstellar wanderers. They arrive not because there is meaning, but because there is motion. Simple, ancient motion through the cold. When you imagine it, imagine something older than most of the stars in our sky, something that has forgotten the concept of home. A drifter with no expectations, no message, and absolutely no sense of timing. As it slipped deeper into the solar system, sunlight fell across it for the first time in perhaps hundreds of millions of years, maybe even longer. Light doesn't always get to greet things out there. Some objects stay in the dark for so long that being illuminated must feel like waking up from a nap that started in a different era. If Oumuamua had feelings, which it didn't, it might have blinked sleepily at the sudden brightness, wondering who left the lights on. It continued drifting, shaped by nothing more than its own momentum. No engine, no plan, no subtle course adjustment suggesting a mind behind the wheel. The simplicity of its behavior is what made it so calming to scientists. It obeyed only the quiet arithmetic of gravity, slipping by each planetary orbit like a ghost unsure whether it should acknowledge the living. And then slowly, astronomers realized what they were looking at. Not a comet from our outer regions, not an asteroid broken from a familiar family, but something new, something that didn't belong to us at all. But here is the gentle truth about its arrival. Nothing dramatic happened. No alarms, no cosmic turbulence, just a faint detection, a line of data made of quiet numbers, and the dawning realization that for the first time in human history, we were watching an object from another star pass by. Something that had been traveling since before our species discovered language, breaking no rules except the ones we assumed existed. And just as mysteriously as it appeared, it kept going, past Earth's orbit, away from the sun, toward the outer dark where heat thins and starlight softens. A visitor that didn't knock, a traveler that didn't linger, a fragment that drifted through our awareness as lightly as a thought, then continued onward, unbothered, unchanged, as if the solar system were nothing more than a brief stop along an endless, silent road. There is a quiet moment after the surprise of discovery settles when humans do something profoundly human. We reach for a name. It's almost instinctual, the way we try to place a word around something the universe has tossed our way, as if language were a soft net we cast over mystery to keep it from drifting too far beyond comprehension. When Oumuamua was first recognized as something not of our solar system, something that didn't match the patterns we knew, the question wasn't just what it was, but what to call it. The name came from Hawaii, the same place where the telescope that spotted it sits, gazing over quiet mountains and darker skies. Oumuamua, a word that in Hawaiian carries the meanings of scout, messenger, one who arrives first, or something sent ahead. The choice wasn't hurried. It was intentional, contemplative, shaped with care. It wasn't meant to assign purpose to the object. It certainly wasn't meant to imply it was a messenger, but rather to honor the way it moved, not stopping, not lingering, simply passing through as if it had come from far away and would continue far beyond. In this sense, the name reflects more about us than about the object itself. Humans name things not because the things require names, but because we do. Names help us anchor the unfamiliar. They give us permission to talk about something that has entered our awareness without warning. They act as small lights in a universe where most things remain unnamed, unseen, or unbothered by our attempts to categorize them. Hawaiian, with its long tradition of oral storytelling and reverence for natural signs, offered a word that was gentle, respectful, and poetic. Scout in everyday English sounds active, almost militaristic. But in Hawaiian context, the word evokes something more fluid, more serene. A forerunner, a first arrival, a quiet visitor who drifts ahead of others not to signal, but simply because the world is wide and wandering is natural. It's a softer concept, one aligned with observing rather than proclaiming, noticing rather than announcing. There's something calming in that resonance. In a time when science communication often leans toward urgency and spectacle, here was a name that asked us to slow down, to take a breath, to appreciate that even in astronomy, where data and measurement guide every conclusion, there is room for a title that feels almost like a whisper. And truly, Oumuamua slipped through our solar system in a way that mirrored its name, quietly, without haste, without insistence. A scout, not because it was sent, but because it arrived before anything else we've ever seen from interstellar space. If the cosmos has stories, this object was a prologue drifting across the page by accident. The act of naming also highlights something quietly profound about human nature. Our need to belong in a universe that very rarely notices us. When something foreign enters our view, whether a star, a molecule, or a visitor from another system, we instinctively try to greet it in our own language. The greeting doesn't need to be returned. It doesn't even need to be heard. The naming is for us, not for the object. Even more beautifully, the name serves as an attempt at humility. Instead of choosing a technical label full of numbers and catalog codes, astronomers allowed culture, geography, and heritage to lead. The sky above Hawaii has long been part of navigational tradition, with stars serving as guides for ocean voyagers. Naming this interstellar traveler with a Polynesian word placed it within a lineage of exploration, not conflict. It connected ancient ocean journeys to the far older journeys made by cold fragments drifting through the galaxy. There is poetry in that parallel. Ocean voyagers reading currents and winds. Interstellar debris riding gravity and starlight. Both moving through vast darkness. Both navigating by forces larger than themselves. Both noticed only when they pass close enough for someone to look up. For listeners drifting toward sleep, this moment, this act of naming, can be a reminder of the quiet ways humans try to understand the unknown. Instead of demanding answers from the universe, we offer it a word. A gentle one, a respectful one. A name that doesn't pretend to explain, but simply acknowledges presence. Scout. A word that makes room for mystery instead of solving it. Naming Oumuamua didn't diminish its strangeness. If anything, it made the strangeness approachable, like giving a title to a character in a story whose origins remain off-stage. Without the name, it could have remained just a number in a catalog, something technical, precise, but emotionally distant. With it, the object became something we could talk about with curiosity rather than confusion. And perhaps that is the soft comfort of this chapter. The reminder that naming isn't a declaration, but an invitation. An invitation to explore gently, to wonder quietly, and to welcome the unknown without fear. Oumuamua may never know it was named. It will continue on, unaware, unchanged, carrying no meaning except the motion it already had. But for us, the name serves as a foothold, one small, human-sized way to touch something that crosses the gulf between stars. In the end, the name does what names do best. It makes the unfamiliar a little less distant, while still leaving room for everything we don't yet understand. Before Oumuamua appeared, humanity had spent centuries mapping the solar system with a kind of slow, persistent diligence, observing planets, charting comets, cataloging asteroids, and assigning orbits the way a careful librarian might label shelves in a room that always seemed to grow. Everything we studied, everything we expected to see, came from here, from our sun, from our family of planets and debris, all sharing a common childhood of dust and gas. And then one day, something didn't. Oumuamua was the first confirmed visitor from another star system ever detected by humans. Not the first one to exist, of course. Interstellar objects have likely been passing through for billions of years, completely unnoticed, slipping by while Earth was still cooling, or while trilobites were deciding which direction evolution felt like going. But Oumuamua was the first one we actually saw. The first one we recognized. The first one that left a trace in our instruments and a quiet ripple in our understanding. And that quiet ripple mattered, not because it demanded urgency, but because it gently shifted the way we think about our place in the galaxy. To appreciate its significance, imagine the solar system as a long, tranquil home where everything has an address. The planets orbit in their loops like dependable residents. Comets wander in from the outskirts like relatives visiting from the edge of town. Even the tiniest rocks have orbits that can be traced back to a common ancestry. Everything belongs, even if distantly, to the same origin story. Oumuamua didn't. Its path was unmistakably foreign, moving too fast, cutting too sharply, and following a trajectory that no local object could mimic. It wasn't bound to the sun. It wasn't circling anything. It wasn't returning from a long loop through the Kuiper belt. It was passing through as if the solar system were nothing more than a wide corridor along a much larger route. And for a brief moment, our carefully organized cosmic home became a hallway. A place with doors that things could enter and exit without belonging to us. A reminder that space, for all its silence, is full of traffic we rarely get the chance to see. The scientific importance of this wasn't earth-shattering. It was something quieter and more profound. It told us that planetary systems do not keep everything they make. They shed fragments. They eject leftovers. They scatter debris during moments of formation, instability, or gravitational shuffling. And those fragments, large, small, odd-shaped, ancient, can travel between the stars, drifting for millions or billions of years before stumbling into another system entirely by accident. Oumuamua was evidence of this cosmic migration, a single piece of proof that our galaxy is not a set of isolated islands, but an interconnected ocean where materials drift freely, not frequently, but naturally, calmly, inevitably. Its discovery also highlighted the subtle skill of observation. The Pan-STARRS telescope in Hawaii detected Oumuamua almost as an afterthought, one streak of motion among thousands. It required astronomers to notice something slightly unusual in that streak. The speed was too high, the direction too odd, the orbit too open. Most of the solar system's inhabitants move in ellipses, curves that loop back to where they began. Oumuamua moved in a hyperbola, a shape that meant it wasn't coming back. It didn't share our sun's long-term plans. This small mathematical detail became the key to recognizing it as interstellar. Not because it made noise, not because it glowed or shook or behaved dramatically, but because the curve of its path told a story only gravity could write. A gentle, elegant story of an object that passed close enough to the sun for its course to bend slightly, and far enough for that bend to be its only interaction. The significance deepened when scientists realized how improbable it was for us to see such a visitor at all. The space between stars is unimaginably vast. The space between wandering fragments inside that interstellar sea is vaster still. Detecting one requires extraordinary coincidence. A fragment must cross our path at the right moment, at the right distance, at a speed slow enough to spot yet fast enough to avoid capture. It's like noticing a single leaf drifting past the window of a submarine deep in the open ocean. Yet here it was, not dramatic, not luminous, not transformative in any immediate sense, just important. Important because it reminded us that the edges of our solar system are permeable, that the boundary between here and out there is not a wall, but a thin haze through which wanderers can drift. Important because it confirmed, gently and without fanfare, that we are not sealed off from the rest of the galaxy. Oumuamua mattered because it was the first time we realized the solar system wasn't just a home. It was also, on occasion, a halfway point. A place that something could pass through on its way elsewhere, without pausing long enough to notice the inhabitants staring upward in amazement. It didn't bring messages. It didn't bring warnings. It didn't change anything overnight. What it brought was perspective. A calm, expansive sense that the universe is more connected than it appears, and that even in the quiet of our cosmic neighborhood, paths from other stars sometimes cross our own. Wanderers glide through, unnoticed for eons, until one happens to align with our gaze. Oumuamua was the first we caught, perhaps the first of many. A reminder that the galaxy is wide, the solar system is open, and sometimes, without knocking, something from far away simply passes by. If there is one thing astronomers appreciate, it is a good, clean shape. Spheres, ellipses, irregular clusters. They don't need perfection, just predictability. Most objects in our solar system fall somewhere along a spectrum that feels familiar. Round if they're massive, lumpy if they're small, stretched if they've endured centuries of rotational stubbornness. Astronomers have become comfortable with this geometric spectrum. Comfort, however, was not what Oumuamua offered. Oumuamua presented a shape that seemed almost shy about committing to any single identity. It stretched one moment, flattened the next, elongated at certain angles and compact at others, like a celestial actor trying out costumes during a backstage rehearsal. Observers on Earth watched its brightness flicker, bright, dim, bright again. Not smoothly, not evenly, but abruptly, as though the object were flashing its different sides in unpredictable rhythms. It wasn't a shape that revealed itself so much as one that teased. This flickering wasn't random. It was the result of light reflecting off a body that tumbled through space, rotating in a way that refused to fall into a neat pattern. The shape wasn't simply odd, it was evasive. Each turn offered a different silhouette, and each silhouette suggested a different possibility. Some angles made it appear long, extraordinarily long, like a tower tipped onto its side and hurled across the galaxy. Other angles made it seem flat, like a cosmic leaf drifting on invisible winds. The universe, for reasons it rarely explains, had carved something that resisted easy categorization. Scientists proposed shapes cautiously, each with the quiet humility of someone trying to describe a shadow cast by an object they cannot touch. Perhaps it was cigar-like, stretched thin by collisions or by rotational stress. Or perhaps it was pancake-like, flattened by eons of gentle erosion from cosmic dust and radiation. Or maybe, just maybe, it was something stranger than either, something no earthly analogy fit neatly. But the key wasn't selecting the correct shape. The key was recognizing that uncertainty is part of the process. Nature does not promise clarity. It doesn't shape objects with the intention of satisfying human curiosity. Oumuamua was a gentle reminder of this, an object that asked observers not for conclusions, but for patience. Astronomers, accustomed to dealing with objects that behave themselves, found delight in the ambiguity. There was no rush to settle the matter, no need to force a verdict. If anything, the evasiveness of Oumuamua's form became part of its charm, a puzzle that wasn't meant to be solved quickly, a quiet invitation to sit with the unknown and allow it to remain unknown for a while. The brightness variations themselves heightened the intrigue. At times, Oumuamua brightened by a factor of 10 as it rotated, far more than typical asteroids. This suggested an unusually elongated shape, perhaps the most elongated ever observed in a natural object. If it were a sculpture on Earth, its proportions would be considered bold, even dramatic. But in space, where drama is typically reserved for supernovas, this kind of shape felt almost whimsical. And yet, because astronomers could only watch it for a short window of time, the shape remained partly speculative. The object moved too quickly, escaped too soon, and reflected too little light for telescopes to capture a crisp portrait. Instead, researchers had to rely on inference, light curves, rotational models, and the occasional gentle sigh as new data deepened the mystery rather than clarified it. Even as hypotheses emerged, there was a sense of restraint. No one tried to force nature to fit their preference. Scientists are capable of embracing ambiguity when it's warranted. In fact, they do it more often than most people realize. Oumuamua encouraged this mindset, rewarding those who allowed uncertainty to sit comfortably in the room. It felt almost like a cosmic test of patience. Could we appreciate an object without fully understanding it? Could we admire a shape that refused to declare itself? The truth is that nature has always produced objects that defy symmetry or simplicity. Rivers carve unpredictable paths. Crystals form odd angles. Clouds drift and contort in ways that elude precise description. Oumuamua's form belonged to this family of natural irregularity, magnified by distance and speed. If humans could accept the whimsical shapes of rocks on a beach, then surely we could accept one drifting between the stars. And in a way, the refusal of Oumuamua's shape to settle became a kind of quiet comfort. It reminded us that not everything has to resolve neatly. Some things are meant to remain sketches, soft outlines instead of defined edges. For scientists, this was an opportunity to model, debate, and theorize without the pressure of finality. For the rest of us, it was a reminder that the universe keeps its secrets not out of malice, but out of sheer scale and indifference. Oumuamua did not owe us a clear silhouette. It gave us hints, glimmers, flashes of reflected light that shaped our imaginations more than our measurements. It encouraged a slower way of thinking, one that rests gently in incomplete understanding. In the end, its shape became symbolic not of oddity, but of openness, a reminder that in a universe filled with billions of stars and uncountable fragments, there will always be shapes that elude definition, objects that pass through our awareness without revealing everything, leaving us with nothing more than a lingering sense of wonder and a softened willingness to let questions remain questions. A shape that refused to settle, and in doing so, taught us the quiet art of settling into uncertainty. Long before anyone on Earth realized it existed, Oumuamua was already spinning, slowly, steadily, and without any particular urgency. In the vast stillness between stars, rotation is one of the few things that remains constant. There are no breaks in interstellar space, no atmospheric drag, no friction to whisper, "Slow down." So an object that starts rotating often continues doing so for longer than entire civilizations exist. Perhaps longer than the stars it once passed. Perhaps longer than its own memory of where it came from, had it possessed such a thing. Oumuamua rotated in a way that was oddly comforting, though scientists would call it tumbling. Not chaotic tumbling, not the kind of frantic spin you might expect from a rock thrown in a hurry, but a gentle, unhurried wobble. A slow turning that suggested nothing dramatic had happened to it in a long time. No collisions, no disruptions. Just the calm persistence of an object obeying old momentum. The rhythm of its rotation created a kind of cosmic heartbeat, not audible, of course, but visible in the faint fluctuations of sunlight reflecting from its surface. Bright, dim, bright, dim. Each change telling telescopes on Earth. Here is a body that spins with a rhythm older than anyone watching. The sequence was steady, but not perfectly regular, as though the object were balancing several axes at once, like a dancer turning slowly in multiple directions without losing their composure. This gentle tumbling revealed something about Oumuamua's past. At some distant moment in its history, long after it formed and long before it arrived here, something nudged it into this motion. It might have been a glancing collision with another drifting fragment. It might have been the gravitational stretch from a passing star. Or it might have been nothing more than the uneven pull of gas and dust near the place it was born. And after that initial nudge, nothing interfered again. For millions, perhaps billions of years, the motion continued uninterrupted. One long, patient pirouette through interstellar emptiness. The scale of that time is easy to overlook. Humans count years. Civilizations count centuries. Planets count orbits. Objects like Oumuamua count rotations, not in days or years, but in epochs. Its steady spinning has likely outlasted ice ages, extinctions, and the rise and fall of countless species on Earth. The rhythm that carried it into our solar system was not new. It was already ancient when mammals were still learning that night was safer than day. And so, when it finally entered our region of space, it did not speed up, slow down, or alter its motion. It simply kept spinning, unbothered by the sun's warmth or the planets drifting around it. That persistent rotation became part of its signature, a quiet indicator that this was no comet or asteroid born from our sun's debris, but a wanderer molded by forces elsewhere. The tumbling wasn't smooth, but it was calm. Scientists call this kind of motion non-principal axis rotation, a phrase that sounds technical but essentially means a rotation so relaxed it refuses to pick just one direction. Most objects settle into a single, stable rotation axis over time, like tops that eventually choose one way to spin. Oumuamua hadn't. It was the cosmic equivalent of reclining in a chair and slowly shifting position every so often. Not because you must, but because it feels natural. Because of its rotation, Oumuamua showed different faces to the sun as it traveled. Each face reflected light differently, giving astronomers snapshots of a surface they never truly saw. The reflections weren't clues to texture so much as a gentle Morse code of motion. A slow conversation carried out in brightness rather than words. In a sleep-focused documentary, this motion becomes almost meditative. Picture an object drifting across a dark, star-filled space, turning softly and steadily. No engine hum, no vapor trail, no flames or sparks or dramatic soundtrack. Just a quiet body gliding through the deep with a rotation that feels like breathing. A long inhale, a long exhale, repeated endlessly. Its motion also underscores something soothing about physics: consistency. In a universe where galaxies collide, stars explode, and black holes reshape space-time, rotation remains one of the simplest, most faithful patterns. An object turns, and unless something interrupts it, it will keep turning forever. There's a beautiful reliability in that. A predictability that echoes the repetition of tides, seasons, and heartbeats. Oumuamua's spin was not symbolic. It had no meaning, but it carried a kind of serene honesty, a motion that asked nothing, demanded nothing, and expected nothing. It just was. And in that gentle tumbling lay a reminder that movement does not need a destination to feel complete. Rotation isn't a journey, it's a state of being, something that can last longer than memories, longer than histories, longer than entire worlds. As it slipped past the sun and began its long departure, Oumuamua kept tumbling exactly as it had before. The solar system's gravity bent its path, but nothing altered its rotation. It left the way it arrived, steady, unhurried, carrying its ancient motion toward the next stretch of darkness. The stars ahead do not care whether it spins one way or another. The emptiness it moves toward will not acknowledge a single rotation. But still it turns, softly, gently, patiently, as it drifts back into the quiet where no one watches. A body spinning through the dark, calm, persistent, and entirely at peace with not being seen. In space where silence is absolute and distance is nearly infinite, most of what we learn comes from watching, not touching, not collecting, not interrupting, just watching. Light becomes the language through which the universe speaks, and astronomers become the patient listeners, tracing meaning from faint flickers rather than from direct encounters. Oumuamua offered no exception to this rule. It passed too quickly and too distantly for any spacecraft to chase. It revealed nothing through heat, nothing through vapor, nothing through sound. What it left behind were changes in brightness, small, rhythmic, almost shy. And from these changes, scientists began to sketch its story. A light curve may sound like something mathematical and clinical, but it is, at its heart, nothing more than a drawing made of brightness. A slow graph of how much sunlight bounces off an object as it turns. For something as small and distant as Oumuamua, light curves were the only way to see beyond a single point of glowing data. And so, astronomers watched. They watched as the object brightened, then dimmed, then brightened again. They watched the cycle repeat. Not perfectly, not predictably, but distinctly enough to reveal motion, shape hints, and surface variation. Each fluctuation was like a syllable in a long, slow sentence. Not a dramatic revelation, but a quiet whisper. And scientists listened with the focus one brings to a soft voice in a calm room. The brightness changes were unusually large, far larger than for typical asteroids. Most small objects show only modest shifts in light as they rotate. Oumuamua changed brightness by a factor of 10, a range so wide it suggested extreme differences in its visible profile depending on which side faced the sun. In simple terms, sometimes it showed us a long, reflective surface, other times, a narrow edge that barely caught the light. These alternating flashes and dimmings formed the basis for the deductions that followed. But light curves do more than reveal shape hints. They also reflect surface texture, rotation patterns, and even how an object wobbles. This meant that scientists weren't just seeing a series of highs and lows. They were seeing a choreography, a slow, irregular dance performed at enormous distance, mapped entirely through the brightness of reflected sunlight. This form of observation is an art as much as a science. It demands the kind of patience that modern life rarely encourages. Attention to small variations, appreciation of faint patterns, acceptance that certainty will come slowly or not at all. Nothing about studying Oumuamua's brightness was rushed. The object itself moved quickly, yes, but the understanding of it unfolded at a pace dictated by the universe, not by human curiosity. There is something soothing about that dynamic. Light curves strip away the noise of speculation and leave only data, calm, impartial, steady, a faint brightening, a gentle dimming, a reminder that nature does not hurry to reveal its secrets. It offers them the way dawn offers sunrise, gradually, softly, without explanation or apology. Astronomers interpreted these curves like quiet clues. For example, when the curve showed a long period of dimness followed by a sudden spike, they inferred a tumbling motion rather than a simple rotation. When the peaks were uneven, they suspected the object wasn't symmetrical. When the curve didn't match anything expected from a local asteroid, they understood that this was truly something from beyond. All of these conclusions came not from direct contact, but from respectful distance. In a sense, the method mirrored the object's behavior. Just as Oumuamua drifted through the solar system without touching anything, humans learned about it without touching it either. Two travelers, one made of rock and ice remnants, the other of curiosity, passing by each other without interference. The process also underscored how much of astronomy relies on what is almost a meditative mindset. Unlike fields where experiments can be repeated on demand, astronomers often get only one chance. One pass of an object, one burst of light, one alignment. Oumuamua would never return, and so its brief visit required an especially gentle attentiveness. The light curves became the closest thing to a conversation we would have with it. From these curves, scientists deduced its rotation period, its approximate proportions, the nature of its tumbling, and even that its surface likely varied in reflectivity, perhaps a mix of smoother regions and rougher patches. Every deduction came not from certainty, but from patterns in the faint glimmer of sunlight bouncing off a distant traveler. It is easy to overlook the beauty in this kind of work. Light curves don't shout. They whisper. They reward those willing to sit with ambiguity, to examine fluctuations that feel almost too subtle to matter. But with Oumuamua, these subtle shifts were all we had, and they were enough. Enough to reveal an object shaped by forces we'll never witness. Enough to trace a rotation older than our species. Enough to glimpse a fragment of a world we will never seize. And perhaps there is comfort in that. The idea that we can learn so much without needing to control or capture. That watching is sometimes enough. That a few quiet flickers of light, carried across millions of kilometers, can become a bridge between worlds. In the darkness of space where sound cannot travel and touch is impossible, light curves become a gentle language. And through that language, Oumuamua spoke, softly, faintly, but clearly enough for those patient enough to listen. In the solar system, comets have a reputation. They arrive with ceremony, shedding material as they approach the sun, releasing tails of gas and dust that glow like banners caught in a slow cosmic wind. Even the quietest comets put on some kind of show, perhaps not a dramatic one, but at least a faint mist, a shimmering breath that tells us, yes, I am made of ice, and yes, the sun is melting me. Oumuamua, however, seemed entirely uninterested in living up to that expectation. When astronomers first tracked its path, they noticed something curious. It was accelerating slightly as it moved away from the sun. Not dramatically, not alarmingly, just enough to suggest some gentle push. This is exactly the kind of motion a comet would produce as it vents gas when warmed by sunlight. But comets always pair this kind of motion with a visible tail or coma, something, anything, a little cloud, a hint of vapor, an apologetic sparkle. Oumuamua offered none. If comets are the extroverts of the small body world, announcing themselves with luminous displays, Oumuamua was the introvert who arrived at the party, nodded politely, then sat quietly in a corner, refusing refreshments. Its motion whispered comet, but its appearance remained firmly not a comet. No plume, no haze, no detectable outgassing of any familiar sort. A performer with all the cues for applause, but no interest in stepping on stage. This mismatch didn't disrupt astronomers. It intrigued them. Science, after all, is most comfortable when the universe behaves unpredictably, but gently so. Oumuamua wasn't threatening. It wasn't alarming. It simply didn't fit neatly into a category. And that gave researchers permission to slow down, breathe, and sit with the puzzle instead of rushing to solve it. The acceleration it displayed, tiny, steady, persistent, felt like a riddle whispered through the dark. Something was pushing it outward, but not in the usual way. It was as if Oumuamua had taken the rule book for comets, flipped to the page titled How to Behave Near the Sun, and decided that particular script wasn't for it. One possibility was that it did release material, but in a way that was too subtle for our telescopes to catch. Perhaps it vented gas that produced no visible dust. Or perhaps the particles were large enough that they didn't scatter light like typical comet tails. Some scientists imagined exotic ices, those that evaporate quietly, without the glitter or glow that water and carbon dioxide produce. Others considered the idea of a thin surface layer insulating the interior, allowing only tiny jets of gas to escape through microscopic cracks. But perhaps the most soothing interpretation was also the simplest. Oumuamua didn't owe us a performance. It was not a comet in the classical sense. It was something else, something from far beyond, carrying materials shaped by environments we have not yet studied. Expecting it to behave like our comets was a bit like expecting a traveler from another continent to follow local customs without an introduction. What made the situation oddly peaceful was the tone of scientific discussion at the time. No panic, no urgent claims, just quiet curiosity. Observatories shared data. Researchers compared notes. Everyone agreed the acceleration was real, and equally agreed that not seeing a tail did not mean a crisis in understanding. Sometimes nature hands you objects that refuse to check the boxes on your form. Oumuamua became a reminder that categories are conveniences, not laws. The universe does not consult human definitions before shaping things, and scientists, comfortable with nuance, welcome the chance to expand their sense of what comets, or comet-like objects, might be. Some theorized that Oumuamua could have been made of hydrogen ice, sublimating invisibly. Others suggested nitrogen ice, or carbon monoxide, or more complex exotic materials that lose mass without glowing. These ideas were presented not as proclamations, but as gentle possibilities, each one a way of honoring the object's behavior without forcing it into a box where it didn't belong. There was even a quiet humor in how the astronomy community handled it. One researcher commented, with understated delight, that Oumuamua was a comet doing the bare minimum. Another suggested it was a comet that had a long journey and ran out of gas a few million years ago. These weren't scientific conclusions, of course, but they reflected an attitude that helped keep the mystery from becoming stressful. When you accept the unknown, it becomes much less intimidating, more like a soft puzzle piece missing from a picture that still makes sense overall. And so, rather than demand clarity, astronomers allowed Oumuamua to remain slightly undefined. A comet that wouldn't behave, or an asteroid that wouldn't stay still. A traveler carrying hints of distant chemistry, holding on to its secrets with all the calm stubbornness of something shaped by environments we can only imagine. Ultimately, the comfort came from accepting that not everything needs to resolve. Oumuamua didn't perform like a comet because it wasn't obligated to. It had a nature formed in another system, under another star, and our categories were merely approximations borrowed from our local experience. Sometimes the universe offers us objects that behave differently simply because they come from elsewhere. And in those cases, the gentle response, the scientific response, is to acknowledge that our definitions must stretch, quietly and without fuss, to accommodate what the cosmos has created. A comet that wouldn't perform, a traveler that wouldn't conform, and a reminder that science sometimes advances not by forcing answers, but by resting comfortably beside the questions. There is a particular kind of mystery that doesn't shout, doesn't startle, and doesn't demand urgency. It lingers softly, like an echo that never resolves into a word. Oumuamua's gentle acceleration was that kind of mystery, subtle enough that most people would have missed it entirely, yet distinct enough to catch the attention of those watching closely. After all, objects passing through the solar system usually follow the clean geometry of gravity. They speed up as they fall toward the sun, slow down as they climb away, and behave with all the predictability of planets that have rehearsed their motions for billions of years. Oumuamua, however, drifted just slightly off script. As it moved away from the sun, it accelerated a little more than gravity alone could explain. Not dramatically, not with any hint of propulsion or force. Just a quiet, steady push, like a sigh of momentum that didn't match the equations perfectly. It was the astronomical equivalent of a leaf floating downstream, and then, for reasons unknown, drifting a tiny bit faster than the current. The effect was small, so small that it required precise measurements to see it at all. But once seen, it became a gentle puzzle, a hint that something subtle was influencing the object's motion. Scientists are used to comets doing this through outgassing, shedding vapor as sunlight warms their ices. That vapor acts like a faint, natural engine, nudging the comet along. But Oumuamua did not reveal any of the usual signs. No shimmering cloud, no glint of expelled dust, no detectable gas. Nothing that would declare, here is the source of the push. And so the mystery remained soft, almost polite. A puzzle without urgency. Instead of dramatizing the possibilities, researchers approached the acceleration with a quiet curiosity. They considered explanations the way one might consider paintings in a gallery, pausing, observing, then stepping back without insisting that one interpretation must be correct. One possibility was that Oumuamua was shedding material in a way too subtle or too clean for telescopes to observe. Some types of ice evaporate invisibly, leaving no glowing trail. Perhaps the surface contained substances that left no dust behind. Exotic ices or crystalline materials shaped by environments our solar system has never produced. This idea drifted into scientific discussion with the lightness of a gentle maybe. Another possibility was that the shape of the object played a role. If it was extremely thin or light relative to its size, sunlight itself might have nudged it along. Photons don't carry much force, but across millions of kilometers, even a small push can add up. A faint shove from solar radiation, operating quietly and continuously, could have contributed to the acceleration. Not a sail, not a craft, just the natural effect of light on a surface shaped by distant circumstances. There were other ideas too, each offered with scientific humility rather than urgency. Perhaps thermal forces were at play, with one side heating and cooling unevenly. Perhaps the tumbling revealed slight asymmetries that shifted the object's center of mass over time. Or perhaps something about its composition allowed it to interact with sunlight in ways not yet fully understood. What mattered most was that the acceleration did not demand a definitive answer. It did not imply danger or urgency. It simply existed, like the faintest ripple on an otherwise calm pond. For astronomers, it became a gentle reminder that the universe does not always reveal the reasons behind its motions, at least not immediately. And that is part of the beauty of studying objects that come from elsewhere, the sense that they carry fragments of histories we can only observe indirectly. Rather than trying to force a conclusion, scientists allowed the mystery to linger. They gathered data, compared models, debated in soft tones across conferences and papers. And in the background, Oumuamua continued on its way, blissfully indifferent to the attention. Whatever caused its acceleration was not dramatic. It was not forceful. It was simply there, a quiet reminder that even small deviations can open large avenues of thought. And there's something soothing in that approach, treating the unknown not as a threat, but as an invitation to wonder. A recognition that curiosity does not need urgency to be meaningful. Some mysteries are best approached with slow steps and open minds, allowing space for, perhaps, to coexist comfortably with we do not yet know. Oumuamua's motion became exactly that kind of scientific meditation. It showed that even tiny forces matter when placed in cosmic scales, that the universe is full of small, patient phenomena that do not demand immediate understanding, and that our knowledge grows as much from listening to quiet anomalies as from observing dramatic ones. As the object drifted farther from the sun, the unexplained acceleration continued for a time before fading into the general motion of interstellar travel. Eventually, it moved too far away for telescopes to track. The light curves dimmed, the data points dwindled, and the mystery softened into a memory, still present, still intriguing, but no longer expanding with new observations. What remains is not a question demanding an answer, but a gentle echo, a reminder that the universe is subtle, layered, and capable of surprising us in the quietest ways. Oumuamua pushed just a little harder than expected. Not enough to alarm, not enough to astonish, just enough to make us pause. Motion without exhaust, a whisper of force with no visible source, a suggestion drifting across the darkness that nature has more ways of moving than we have words to describe. And sometimes, the softest mysteries are the ones that linger the longest. Long before Oumuamua wandered into our solar system, long before Earth formed its oceans or the sun settled into its mature glow, it was someplace else entirely. Not just far away in distance, but distant in time, shaped by forces that cared nothing for destinations or discoveries. To imagine its past is not to assemble a dramatic biography, but to picture the slow, indifferent processes that sculpt objects between the stars. The story begins in a place humans will never visit, a stellar nursery. Not a single site, but one of countless regions where gravity slowly gathers clouds of gas and dust into something dense enough to ignite new stars. These nurseries are not peaceful in the human sense. There are bursts of energy, waves of radiation, and winds from hot young stars carving paths through the dust. But they have their own quiet rhythm, their own cycles of collapse and expansion that continue for millions of years. Somewhere within such a region, long before humans existed to imagine it, Oumuamua's raw materials were gathered. They were not special, just bits of dust, fragments of rock-forming minerals, ice particles, and the usual ingredients that drift through the galaxy waiting for gravity to nudge them together. Over time, those particles clumped, merged, compacted, perhaps slowly at first, then with increasing momentum as local gravity encouraged growth. Eventually, a larger solid body formed, not a planet, not a comet, not an asteroid, but a leftover fragment from a system that was still deciding what it wanted to become. Objects like this are not rare in star-forming regions. They are the byproducts of planetary construction, the debris produced when young systems fumble through the process of arranging themselves. Much like a workshop littered with scrap, stellar nurseries shed fragments during their busiest phases. Some fragments become part of planets. Others collide and shatter. Many linger in distant orbits. And some, like Oumuamua, are flung outward entirely. The ejection may have been gentle or violent. Gravity allows for both. A passing star might have brushed too close, its pull destabilizing orbits and sending smaller objects flying. Or perhaps a giant planet in its own system tugged Oumuamua close and then released it with enough momentum to escape not only that planet's gravity, but the gravity of the entire system. A simple, quiet eviction from its birthplace. Once freed, the object entered interstellar space, a realm defined mostly by absence. No warmth, no light strong enough to shape it further, no neighboring bodies to collide with. Just cold, thin emptiness stretching in every direction. Yet even emptiness can create change, given enough time. Cosmic rays, the high-energy particles that roam between stars, slowly chipped at its surface. Micrometeorite dust occasionally struck it, ever so softly altering its exterior. Radiation darkened whatever ices or minerals coated it. Over the course of millions of years, then billions, Oumuamua became less like the object it once was, and more like an artifact of time itself. This long drift through the interstellar medium did not require drama. It didn't require a reason. It simply happened because motion, once begun, continues. This is endurance by default rather than design. The persistence of an object that nothing interfered with strongly enough to break or redirect. It traveled through regions shaped by stellar winds, through patches of diffuse dust, through shadows cast by nebulae. It passed by stars without pausing, came close to others without being captured, and slipped through the galaxy with the kind of unhurried patience only the universe can produce. Every so often, it may have passed within sight of a star bright enough to illuminate it faintly. But most of its journey was spent in near total darkness. A darkness so complete that even the idea of light becomes almost theoretical. Yet there is a calmness in that darkness, a constancy that life-bearing planets rarely experience. No seasons, no orbits, no cycles, just drifting, quietly, through distances so large they defy intuition. During these ages of travel, Oumuamua changed not because it sought transformation, but because time itself acts like a sculptor. Faces weathered by radiation, edges softened or sharpened by random impacts, surfaces darkened until they reflected sunlight in uneven, mysterious patterns by the time they finally reached our telescopes. This history, imagined through physics, not fantasy, suggests endurance shaped by indifference. The universe did not preserve Oumuamua intentionally. It simply did not destroy it. There were no guiding hands, no protective forces, no deliberate preservation. Its survival was not a triumph. It was a continuation. When it finally drifted near our solar system, nothing about its arrival suggested purpose. It did not target the sun. It wasn't drawn by anything we did. We simply happened to be in its path for the briefest moment in its long journey. Like a grain of dust on a breeze passing by an open window, it entered our field of view only because timing allowed it. This perspective makes its visit strangely comforting. Oumuamua was not a messenger. It was a reminder of how much exists beyond our awareness. How many objects wander the galaxy without destination? How many fragments endure not because they are strong, but because the spaces they travel through are vast and mostly empty? In imagining its origins and its long journey, we find not drama, but quiet continuity. Oumuamua was made elsewhere, shaped slowly by forces that do not care who is watching. And in its endurance, we see a kind of cosmic patience, an object that traveled across unimaginable distances simply because nothing stopped it. Endurance through indifference. Survival not by effort, but by drifting gently through a universe vast enough to forget what it created. When Oumuamua first appeared in the data, slipping silently into our awareness like a forgotten bookmark falling out of a closed book, it didn't take long for excitement to bloom. Humans are imaginative creatures, especially when confronted with something unfamiliar. A visitor from another star system? A shape we've never seen? A motion that didn't quite follow expectations. For some, the leap from mysterious to meaningful came quickly. But the truth, in its gentlest form, is this. Oumuamua was interesting, but not intentional. A traveler, not a messenger. A fragment, not a signal. The universe, as far as our best understanding goes, does not send objects as letters across the void. It simply lets things drift. A shard broken from an ancient world does not carry purpose. It carries momentum. And yet, we humans are wired to look for patterns, to find meaning where there might be only motion. It is both our gift and our habit. So this chapter becomes a soft, calming correction, not to quiet curiosity, but to quiet urgency, to remind the listener that wonder does not require drama, and significance does not require intention. Oumuamua felt different because it was different. But difference alone does not imply message. Its elongated form or flattened form, depending on which angles the light hinted at, was strange simply because it came from elsewhere, an environment with its own history, chemistry, and accident-filled formation. Its acceleration was unusual because its makeup was unusual. Its presence was rare, not purposeful. These qualities, shape, motion, origin, are fascinating for what they teach us about the galaxy, not for what they might be trying to tell us. They speak to natural processes unfolding across millions of years, not to deliberate communication. And in this way, Oumuamua invites a quieter kind of wonder, the wonder of observing something without needing it to explain itself. Part of the reason sensational ideas took hold is that we rarely encounter interstellar objects. When the unfamiliar arrives, it is tempting to assign meaning. If we found a perfectly round stone on a deserted beach, some might imagine a hidden hand shaping it, even if waves alone could have done the job. The mind fills gaps with stories before science fills them with data. But in astronomy, the simplest explanation is usually the calmest one. Stars form, planets form, fragments break away, and cosmic currents scatter them across the galaxy. Sometimes one of those fragments happens to pass near a star system that contains a species capable of noticing. It is coincidence on a grand scale, but not purpose. Moreover, Oumuamua behaved like a natural object from the moment it entered our telescope's vision. Its brightness fluctuated as it tumbled. Its surface reflected sunlight in uneven organic patterns. No signals came from it. No radio waves. No structured pulses. Nothing that hinted at design. If it were engineered, it would have been the universe's most dedicated minimalist project, one committed to erasing every trace of intention. The gentle truth is this: sometimes the universe simply sheds fragments the way trees shed leaves. Not because the leaves are messages, but because shedding is what trees do. Planetary systems, like trees, generate excess. During their formation, countless bits of rock and ice are flung outward. Most never meet another star system. A few do. Oumuamua was one of those few. Its visit reminds us not only of the scale of the galaxy, but of its neutrality. The cosmos is not hostile, nor is it communicative. It is indifferent, but not in a cold or lonely way. More in the way a mountain is indifferent to who climbs it. The mountain exists whether or not anyone reaches it. Likewise, Oumuamua traveled through the solar system whether or not anyone noticed, and yet, noticing made the moment meaningful for us. That is perhaps the most calming part of this story. Meaning is something humans bring to the universe, not something the universe sends to us. The significance of Oumuamua comes from our own curiosity, our ability to observe, to question, to wonder at the existence of objects formed in distant, forgotten corners of the galaxy. The object did not arrive to deliver significance, but we gave it significance by looking up at the right time. This chapter, then, is a soft reminder that wonder does not depend on special messages. The beauty of Oumuamua lies precisely in the absence of intention, in its ability to inspire curiosity simply by existing, in the reminder that nature produces surprises without needing to be dramatic. A fragment passing by is not a signal, nor is it a warning or a clue or a coded story from another world. It is evidence of motion older than memory, older than sunlight, older than the path it briefly shared with us. It is a quiet demonstration that the universe is full of objects we have never seen, objects we may never see, and that each one carries a timeline shaped by forces far beyond our own world. Their presence does not demand an interpretation. They are allowed to be what they are. Drifting remnants, shaped by time, noticed by chance. And so, Oumuamua asks nothing from us except attention, gentle, patient attention. It does not shout meaning, it whispers existence. Not a message, not a sign. Simply a visitor passing through a doorway we rarely realize is open. A reminder that sometimes wonder is enough. For all the centuries humans have spent studying the night sky, charting constellations, tracking planets, naming comets, and cataloging stars, Oumuamua occupied our awareness for only a moment, a handful of weeks, a blink, even by human standards. It arrived quietly, was noticed almost by accident, stayed long enough to spark curiosity, and then slipped away before most people even learned how to pronounce its name. If cosmic time were a river, Oumuamua touched the surface like the faintest ripple and was gone before the water even remembered it had been disturbed. This brevity is not a flaw in the story, it is the story. Human attention, for all its intensity, is fleeting. Our news cycles crave momentum. Our days fill with tasks. Our minds drift toward new concerns with predictable haste. But cosmic attention operates differently. if it can be said to exist at all. The universe does not observe or notice. It does not mark beginnings or endings. It simply continues, letting objects travel on their trajectories without commentary. Oumuamua moved according to the quiet logic of momentum, not deliberately brief, merely unbothered by the timescales that matter to us. And so a moment of overlap occurred. One small slice of its long journey intersected with a brief stretch of our awareness. A fleeting alignment. A coincidence that felt meaningful not because the event lasted long, but because it occurred at all. To place this in perspective, imagine its passage from a cosmic viewpoint. For millions or billions of years, Oumuamua drifted between stars, unlit and unnoticed. Then, for a brief time, mere hours in its own travel, it swooped close enough to the sun to brighten, close enough to Earth to be detected, close enough to human curiosity to earn a place in our telescopes. During this brief interval, an entire community of scientists turned their attention toward it, racing gently to gather information before the object faded into distance again. The rush was not frantic. It was more like trying to remember a dream just after waking, grasping details quickly because they evaporate if given too much time. By the time most telescopes focused on it, Oumuamua was already leaving. Each night, it grew dimmer, its brightness falling not because it wanted to leave, but because it simply did what interstellar objects do. It moved on. Even before public fascination reached its peak, the object was too faint to observe in detail, slipping past the limits of our instruments. In that sense, the duration of human engagement was not decided by choice or attention span, but by the quiet reality of physics. Yet in those brief days, the world felt just a bit larger. Headlines appeared. Questions rose. People who rarely thought about astronomy paused to wonder. Not because Oumuamua demanded it, nothing about the object asked for attention, but because its rarity sparked a moment of shared curiosity. A visitor from elsewhere. A glimpse of material shaped by another star. A reminder that our solar system is not closed off, but open to wanderers who drift through at their own pace. And then, in typical human fashion, the collective focus shifted. There were other stories, other concerns, other discoveries. Oumuamua receded into memory not dramatically, but naturally. Just as shooting stars burn briefly and leave contented darkness behind, Oumuamua's significance remained without insisting on itself. This brevity invites reflection on how humans perceive importance. We tend to associate significance with duration, long projects, lasting symbols, enduring events. But Oumuamua's passage suggests a gentler truth. Something can matter deeply even if it appears only once, only briefly, and only in passing. Its impact on human understanding was not diminished by its speed. If anything, the shortness of its visit made it more precious. In cosmic terms, brevity is the norm. Stars flare for milliseconds. Subatomic particles wink into existence and vanish. Even galaxies collide over timescales that feel instantaneous compared to the universe's long, quiet expansion. By comparison, Oumuamua's visibility was practically leisurely, offering scientists weeks rather than moments. But human attention doesn't always stretch to meet cosmic timing. Much of the world missed the moment entirely. Many learned about the visitor only after it had gone. Some dismissed it as a scientific curiosity, interesting perhaps, but not compelling enough to linger in thought. And this is where the contrast becomes soothing. The universe doesn't mind. Oumuamua didn't arrive to be witnessed. It didn't measure its significance by the number of eyes watching. Its path existed long before we noticed and will continue long after we forget. There is comfort in acknowledging that our awareness is not required for cosmic processes to unfold. It frees us from the pressure to understand everything immediately or to hold on to every celestial event. Some things pass through our awareness briefly, and that is enough. They enrich our understanding in small but meaningful ways, offering perspective without demanding permanence. Oumuamua reminds us that attention can be momentary and still profound. That a brief encounter can expand our sense of scale, stretch our imagination, and remind us that the universe is filled with wanderers we will never meet. We do not need prolonged observation to appreciate rarity. Sometimes noticing is its own reward. By the time the object vanished into the deepening dark, heading toward constellations that shift only over millennia, it had already reshaped our understanding of the solar system. Not by staying, but by passing. Not by speaking, but by being seen. A visitor that lived in our awareness for a moment that mattered, precisely because it did not last. When Oumuamua passed through the solar system, the idea of chasing it lingered briefly in scientific discussions, an understandable reflex, the way one might feel a momentary temptation to follow a rare bird slipping across a quiet forest path. But that impulse faded quickly, replaced by the calm recognition that our technology, remarkable as it is, arrived just a little too late. Not tragically late, not frustratingly late, simply late in the gentle, unsurprising way civilizations often find themselves, present, but not yet prepared for every possibility the universe offers. In truth, even if humanity had made the decision instantly, within minutes of its discovery, no spacecraft was available that could have caught up. Oumuamua moved with a speed shaped by eons of interstellar travel, traveling faster than any human-made object to date. By the time telescopes noticed it, it was already receding, already accelerating away from the sun, already slipping into a region of space where distances expand faster than our propulsion systems can manage. This gap between discovery and capability is not a failure. It is the natural state of a species still learning to stretch. Human exploration has always unfolded like this. We notice mountains long before we can climb them, glimpse distant continents long before building ships to reach them, and observe planets long before sending probes to orbit them. Curiosity leads. Technology follows, sometimes decades or centuries later. Oumuamua appeared in the brief interval between those two steps. Our curiosity was ready. Our instruments were alert. Our abilities were close but not quite aligned. Even imagining an intercept mission underscores this timing mismatch. The fastest spacecraft ever launched, like Voyager 1 or the Parker Solar Probe, move at extraordinary speeds by human standards, yet still slower than Oumuamua's departure velocity. To catch it, a probe would need not only unprecedented acceleration, but years of planning and engineering that simply weren't available. Interstellar visitors do not pause while civilizations prepare. They pass, and we learn what we can from the distance available. But this realization is not discouraging. If anything, it offers a kind of calm perspective. Science advances on human time, not cosmic time, and the two rarely align. We live in a chapter where noticing an interstellar object is already a triumph, something that would have been impossible only a century ago. The ability to track its brightness, measure its motion, and discuss its characteristics across the world in real time marks extraordinary progress. The fact that we couldn't chase it is not a sign of inadequacy. It's a reminder that we are still early in our technological story. This pattern repeats throughout history. Dinosaurs roamed Earth for millions of years without ever glimpsing another world. Humanity, in a few thousand years, went from shaping stone tools to sending robotic explorers to Mars. Progress unfolds unevenly. Brilliant leaps surrounded by long stretches of preparation, trial, error, and quiet building. Oumuamua visited during one of those stretches, a moment when our vision outpaced our reach. Some proposed clever ideas: solar sails, high-velocity interceptors, gravitational slingshots. But these were sketches for the future, not tools available in the moment. Even the most optimistic designs required years of development and testing. By the time such a mission could be built, Oumuamua would be far beyond the range where sunlight or radio waves could help us track it. We would not even know exactly where to send the spacecraft. Following an object that small, that dark, and that distant becomes a losing race the moment it moves beyond our observational horizon. And yet this doesn't diminish the excitement of future possibilities. Oumuamua served as a quiet nudge, a reminder that interstellar visitors are not once-in-a-lifetime rarities, but part of a larger population we are only beginning to detect. The awareness that more may come encourages preparation, not out of urgency, but out of patient anticipation. Instruments are being designed, missions are being imagined. Technologies are being refined for a future encounter that may unfold differently. Civilization often arrives at crossroads like this, close enough to see the path, but not yet able to walk it. It happened in ancient navigation, where stars revealed possibilities long before ships could follow them. It happened in early astronomy, when telescopes revealed moons orbiting Jupiter long before rockets existed to visit them. And now, it happens with interstellar objects, which we can spot and study but not chase. Not yet. What feels, on the surface, like limitation is actually the gentle pacing of progress. Science rarely moves in perfect synchrony with discovery. Instead, it moves in waves. Observation inspires ambition. Ambition inspires innovation. And innovation enables the next observation. If Oumuamua had arrived even a few decades later, the story might have been different. If it had arrived a century earlier, we wouldn't have seen it at all. Its timing was neither early nor late. It simply was. And we, with all our instruments and curiosity, took from that moment what we could: data, ideas, questions, and a renewed sense of how much there is still to learn. The gap between noticing and reaching became not a frustration, but a meditation on patience, on the slow growth of capability, on the understanding that human progress is measured not by what we can catch today, but by what we prepare ourselves to catch tomorrow. Oumuamua did not expose a failure. It highlighted potential, quietly, gently, in passing. A reminder that our technology is growing, that our awareness is expanding, and that sometimes the universe taps softly on the window before we've finished building the door. Before Oumuamua arrived, it was easy to imagine the space between stars as a kind of vast emptiness, a quiet vacuum with very little drifting through it, besides the distant glow of gas clouds and the occasional starlight stretched thin across immeasurable distances. But emptiness is often a matter of perception, not reality. What feels empty to us may simply be filled with things too small, too faint, or too quiet to draw attention. So when astronomers realized that Oumuamua was the first interstellar object we had ever detected, an interesting thought followed with gentle inevitability. What if this wasn't rare? What if this was only the first one we happened to see? The universe, after all, doesn't tend to produce singular events. Nature works in quantities: countless stars, countless planets, countless small debris ejected during the turbulent early years of planetary formation. If one piece of interstellar rubble reached us, the simplest explanation is that many more have drifted through, unnoticed, long before we had instruments sensitive enough to catch them. This idea is not unsettling. It doesn't suggest hidden visitors or secret activity. Instead, it offers a calming perspective on the scale of things, a reassurance that the galaxy is full of quiet wanderers, drifting peacefully, posing no threat, carrying no messages. The only surprising thing is that we rarely see them, not because they're sneaking past us, but because we've been looking for other kinds of objects entirely. Interstellar fragments are small. They don't shine. They don't warm up unless they pass very close to a star. They reflect only the faintest slivers of light, like tiny stones tossed across an ocean at night. Most pass through star systems far from the planets. Others pass near planets, but remain invisible against the overwhelming backdrop of space. A few brush past Earth's orbit, but at distances where even our most powerful telescopes would fail to notice them. Oumuamua was detected not because it was exceptional, but because our monitoring systems are finally becoming sensitive enough to see objects of its size and brightness. We were lucky. Our instruments happened to be watching the right patch of sky at the right moment. That combination of chance and technology is new to human history. The rest, countless unseen travelers, passed by while we were still learning to look. This idea reframes the concept of cosmic solitude. The interstellar medium is not a barren desert, but a quiet driftway, where debris from millions of early planetary systems quietly circulates. It is a reminder that worlds form with exuberant generosity, scattering fragments the way trees scatter seeds. Most land nowhere special. Some travel unimaginable distances. A few wander close enough to another star system to be illuminated briefly by a sun they've never seen before. And every once in a long while, one crosses paths with a civilization capable of noticing. Oumuamua's detection inspired models that estimate how many interstellar objects might be passing through the solar system at any given moment. The answer is surprisingly comforting. A steady population of wanderers, drifting through on predictable, quiet trajectories. Some the size of small buildings, others no larger than pebbles, none carrying intention, all carrying the subtle signature of the systems they once belonged to. The absence of sightings, then, is not a sign of emptiness. It is a sign of limitation, and those limitations are shrinking. Wide-field surveys, automated sky scanners, and faster detection algorithms now watch for faint streaks of motion that would have been invisible only a decade ago. With each improvement, the quiet background population becomes more visible, like stars emerging one by one as the twilight deepens. Rather than feeling crowded, this knowledge brings a strange serenity. These objects are not intruders. They are not anomalies. They are the quiet residue of a galaxy that has been forming, dissolving, reshaping, and exchanging material for billions of years. They drift not with purpose, but with patience, following paths shaped long before our planet had oceans. To think of many such objects passing through the solar system is to imagine a gentle, continuous migration, unseen travelers crossing a landscape that scarcely notices their presence. They do not influence planets. They do not disturb orbits. They pass through quietly, like birds migrating across a vast wilderness without landing. This understanding also shifts how we think about the solar system itself. Rather than an isolated bubble, it becomes a crossroads, one where foreign debris occasionally drifts by, carried by currents we cannot see. The presence of these wanderers connects us subtly to distant stars, to planetary systems we will never visit, to worlds that might have existed long ago, or might still exist somewhere in the galaxy's great unfolding. In this sense, absence becomes presence. The emptiness of space becomes a gentle fullness, filled not with noise or activity, but with the quiet motion of countless fragments drifting through. Most will never be detected, but their existence makes the universe feel less like a void and more like a place alive with natural exchange. Oumuamua was just one example, one that happened to cross the threshold of human perception. Now that we know what to look for, more will follow. Not because the universe changed, but because our awareness of it has grown. The silence of interstellar space remains, but inside that silence is a steady, unseen traffic, harmless, natural, and beautifully mundane. A population we rarely notice, not because it hides, but because it has always been there, drifting with the quiet patience of things that were never meant to be seen, yet comfortingly real once we finally do. When Oumuamua entered the solar system, it did so without introduction, and when it left, it offered even less. No deceleration, no final flare of reflected sunlight. no gesture acknowledging that it had passed through a realm of planets, instruments, and curious eyes. Its departure mirrored its nature, quiet, steady, and unbothered by whether anyone was watching. By the time most people on Earth learned its name, Oumuamua was already receding into the dim outer reaches, moving past distances where sunlight falls thinly and shadows stretch into near eternity. Telescopes strained to track it, their images growing fainter each night. Observers leaned on longer exposures, more sensitive detectors, creative modeling, anything to keep the visitor in view just a little longer. But sensitivity has limits, and those limits approached gently, like dusk creeping across the sky. Eventually, the images faded completely. The object didn't wink out or vanish. Nothing so dramatic. It simply became too far, too faint. A speck dissolving back into the anonymity of interstellar space, like watching a distant boat drift toward the horizon until it blends with the sea. Its separation from us felt natural, inevitable, and strangely soothing. The solar system itself did nothing special to mark the moment. Gravity bent Oumuamua's path one last time as it climbed away from the sun, its trajectory tracing a wide, open arc that confirmed it would never return. Not next century. Not next millennium. Not ever. It would continue outward, following the same subtle acceleration it had shown before. Still unexplained, still gentle, still utterly indifferent to our questions. Its retreat was unhurried. Even at extraordinary speeds, movement through such emptiness feels slow, like gliding rather than racing, floating rather than flying. There is no friction to warm it, no atmosphere to carve its edges, no sound to accompany its motion. Just the steady unfolding of distance, marked only by the decreasing brightness of reflected light. As it passed beyond the reach of detailed observation, something curious happened. Not in the sky, but here on Earth. Our collective imagination, so briefly caught up in the story of this wanderer, began to settle again. The questions quieted. The speculation softened. Curiosity remained, but it shifted from active puzzling to a more reflective kind of wonder. Oumuamua no longer felt like a mystery demanding solutions. It felt like a moment that had come and gone, leaving behind a calm appreciation for what little we had been allowed to see. This kind of ending, a non-ending, really, is rare in stories humans tell. We're accustomed to finales that resolve, climaxes that echo, characters who wave goodbye or turn dramatically at the threshold. Oumuamua offered none of those luxuries. Its exit was not a departure so much as a continuation, the resumption of a journey that had been ongoing long before humans existed and will likely continue long after we are gone. And there is peace in that. As it moved farther from the sun, the warmth it briefly encountered faded. The object returned to the temperature of deep space, cold so profound that heat becomes a memory rather than a measurable quality. Radiation softened, light diminished. The sun became just another star behind it, shrinking slightly with each passing moment, until even our star's glow would appear no brighter than countless others in its sky. One can imagine the scene, not scientifically, but gently. Oumuamua drifting among the quiet fields between stars, carrying the subdued reflections of the worlds it passed near but never touched. Not a relic with a story, not a messenger with a mission, simply a persistent traveler continuing on its way. If the planets noticed its departure, which they didn't, they would have done so with the same indifference they showed during its arrival. Jupiter continued circling. Earth kept spinning. The moon pulled our tides. Nothing in the solar system shifted in response. And that is what makes this chapter calming. The reminder that celestial events do not require human-like drama to be meaningful. Oumuamua's exit allowed astronomers to rest in the knowledge that some stories are meant to be open-ended, not unfinished, not incomplete, just ongoing, far beyond the horizon of our observation. In a world where we often seek closure, there is something deeply restful about accepting a narrative that continues without us. As it drifts farther into the dark, the object becomes increasingly hypothetical in our minds. An idea more than a presence, a trajectory more than a shape. It becomes a memory of light curves, a set of coordinates fading gradually into uncertainty. And yet, this fading does not feel like loss. It feels like the natural exhale after a slow, attentive inhale. The farther Oumuamua goes, the more the universe absorbs it back into its quiet rhythms. There are no markers to track its progress, no milestones in the void. Only the ongoing journey of a fragment shaped by a star we will never know. And as it continues, our thoughts can slow with it. No rush, no anticipation, no need to keep pace. Just the understanding that somewhere out there, beyond planets, beyond orbits, beyond even the sun's reach, Oumuamua keeps moving with the same soft persistence it has always had, leaving without ceremony, leaving the way it lived, and reminding us gently that not everything extraordinary stays for long, nor does it need to. There is a particular softness in mysteries that do not press for answers. Mysteries that do not loom or demand, but simply drift through awareness like a quiet breeze across still water. Oumuamua, in the end, became one of these. Not a riddle to be solved urgently, not a puzzle demanding assembly, but a gentle reminder that the universe allows room for uncertainty. And in that room, there is space for calm. As it slipped away from the solar system, it also slipped from the grasp of certainty. The questions it raised about its shape, its origin, its slight acceleration, its quiet passing, remained open. Some theories came close to plausibility, some rested comfortably in maybe, and some floated in the realm of interesting, but probably not. Yet none delivered a definitive conclusion. Oumuamua offered hints, not answers, glimpses, not revelations. For many scientific stories, that would feel incomplete. But for this one, incompleteness becomes the essence. The beauty lies in the fact that we do not know, and may never know, everything about the visitor. Like distant mountains seen only in twilight, part of the charm is the fading of detail, the acceptance that some features will remain silhouettes forever. The human mind is built to seek patterns, to stitch meaning into loose threads, to fold ambiguity into understanding. Yet there is another part of us, quieter, slower, that can rest comfortably in the unknown. That part recognizes that not every phenomenon exists to be decoded. Some simply are. Oumuamua becomes a symbol of that gentle category. Things that come and go without explanation, that remain remarkable precisely because they do not resolve neatly into boxes or labels. It reminds us that curiosity does not always require closure. Sometimes it is enough to witness a moment and let it pass, carrying the experience rather than the explanation. In this closing chapter, the uncertainty surrounding Oumuamua becomes a source of calm. Instead of urgency, it invites reflection, a moment to consider how vast the galaxy is and how little of it we have seen. The object's brief appearance gestures toward the enormity beyond our reach. Regions filled with countless fragments, worlds forming and dissolving, materials drifting quietly through interstellar space without names, classifications, or histories recorded by anything conscious. When we accept the unknown, the universe becomes larger, not smaller. There is comfort in that scale, comfort in remembering that we are not required to illuminate all of existence. Comfort in knowing that some mysteries exist beyond the horizon, not to frustrate us, but to remind us of perspective. Our understanding of the cosmos is an ongoing story, not a finished book, and Oumuamua is a single graceful sentence, one that trails off into ellipses rather than ending with a period. Some imagined that its arrival carried meaning, but what it truly carried was possibility. Possibility that interstellar objects drift through regularly. Possibility that materials from distant systems brush past us more often than we realize. Possibility that the galaxy is connected through quiet exchanges rather than dramatic encounters. Possibility, not purpose. And when we release the need for purpose, the experience becomes peaceful. Oumuamua's ambiguity is not a flaw in the narrative, but its most soothing feature. It allows us to breathe into the unknown rather than struggle against it. It gives permission to step back, to widen our gaze, to let the story end without tying every thread. The universe does not explain itself. It does not send instruction manuals or post clarifying updates. It is content to exist without annotation. And yet, despite this, or perhaps because of it, it remains breathtaking. Stars expand and collapse without asking to be interpreted. Nebulae form new suns without issuing announcements. Galaxies collide without drama, without intention, simply following the quiet pull of gravity. Oumuamua fits perfectly within that tradition of calm, unintentional beauty. Its brief visit left us with more questions than answers, but also with a deeper sense of space, both literal and emotional. It reminded us that wonder can arise from what we do not know just as much as from what we do. The unknown is not a void. It is a landscape, a place where imagination, humility, and curiosity coexist. As the object continues into the dark, far beyond our reach, its mystery remains intact. It becomes part of the unseen background of the galaxy once more, a wanderer with no audience. Yet what it leaves behind in human memory is a quiet appreciation for the limits of knowledge and the serenity found at those edges. There will be other discoveries, other visitors, other moments when the universe taps softly on the window before disappearing again. Some will be clearer, some even stranger, some perhaps more familiar. But none will replicate Oumuamua's gentle reminder that the universe does not need to be understood to be beautiful, that some things pass through our lives briefly and still change us. That mystery, when allowed to remain mystery, becomes a kind of peace. And so the story closes, not with an answer, but with a breath, a widening silence, a lingering sense of scale, the comfort of not knowing, carried gently through the dark.